a quick little demonstration of Lab 4 pulse width modulation. What we'll need for this lab is a servo motor. So this is a limited servo motor. It's not the continuous running servo motors that you'll be using for your wheels, but this one here will only go between 0 and 180 degrees. Our Arduino Nano, and a few LEDs, a few switches, and some extra 10K resistors for our couple of switches. The first part of Lab 4, we need to hook up some LEDs. So we need to hook up an LED to pin 5 and connect some switches with pull-up resistors to pin 7 and pin 8. We'll also connect our servo to pin 9, and then we'll get ready for some coding. So I'll just hook these up now quickly. So we're going to get our little switches and we're going to place them into our board. I'm going to place them over here. Switch 1 and switch 2. Now our switch 1 is going to be connected to pin 7. So there's our pin 7. I'm going to connect switch 1 up to that. And our second switch is going to be connected up to pin 8. There we go. The other end of our switch is going to be connected up to ground. I'll connect that up to my ground connection. Just lay them down. And our ground will connect up to our ground on our Arduino. Our LEDs, well, they're going to be an active low driven, so these LEDs will be from the positive rail going down into our Arduino, so this will connect up to our 5 volts. I'll just make sure that all my LEDs are in the right way. There we go. And I'm going to hook up one of my LEDs up to pin 5. There it is, into pin 5, D5, there we go. Now I haven't finished wiring up my switches. I need my 2 pull-up resistors in there as well. So they're going to go from that same side as my connection to my microcontroller, same side. That's going to go into the 5 volts. So they're pulling up that point, so into the 5 volts. And what we've noticed is some of these breadboards in the labs need to actually have a connection across this blank spot here. My one doesn't, as you'll see there, it's got the lines that go right along the entire length, so the coloured lines go right along the entire length. If yours does, all you need to do is connect up a wire, and that'll just jump it over. Okay. Part 2, setup pins. For this we will set up the types of pins that we will be using, so our input pins being our 2 switches and our LED being an output. So first what we're going to do is we're going to declare the pin numbers. So above our void setup we will declare some variables. So int, and we'll have it as LED 0, and that's on pin 5. And our 2 switches, switch 0, and we'll have that on pin 7. And our switch 1, which is exactly the same as the previous, but on just pin 8. Okay. Now that we've done that, we can start to set up our actual pins. So in here we're going to write pin mode, and we're going to do LED 0, and the direction of this is an output, and then we've got our 2 switches, and don't forget to put at the end our semicolons to close off the lines. Okay, so we've defined our pins and the way that they're going to operate. The next thing that we need to do is we need to write a little bit of code that will enable us to use these pins. So at first point, just to make sure that this is working, we will just write all 1s or all 0s to our LED. So maybe we'll do an LED so LED 0, and we will say that's low. Wait 1 second. Write it high, and wait 1 second again. Okay. Click verify. Plug in our Arduino. Make sure that our board is set correct. Yes, port 38 for me. Yours will be a different port. It will never be COM port 1, and most time it'll be COM port 3 or something above 3. Yep, no, so we should be right. Let's program that. And there we go, our LED's blinking, that's good, that's a good sign. Now what we'll do is we will now write to our LED the value of our switch. So in here where we have our digital read and write, I'm just going to get rid of these delays. So LED 1 will be equal to the digital read of SW0, and I'll upload that. Okay, let's push the button. There we go, so that works, that's great. Let's also check that our other switch works. Upload that, change the SW0 to an SW1, and let's have a look and see if that also works. Yes, there it does, and our other switch should do nothing. Yep, excellent. So that's all working. Alright, so I can delete this now, and we can move on to the next part of the lab. Okay, for the next part now, what we'll need to do is we'll need to analog write a value to our LED. Now, when we do this, what we're going to do is we're going to say analog write LED 1, and then put a number there. Now, that number that we put there will determine how many times that output pin, which is connected to, well, what is it, D5, which is connected to our LED, and it'll determine how many times that turns on and off. So the ratio of which it's turned on, being a logic high, versus being off. So if we say analog write LED 0, comma 0, what that means is that the pin will be high 0 of the time and be low for the remaining of all the time. So out of 0 to 255, in that division, 255 pulses will be low and 0 of them will be high. If we make that number half of that, 128, that means half of the time the LED will be given a 5 volt output from D5, and the other half of the time, the other 127, will be 0 or a low, which means that the LED will be on during that time, but it'll be spend half of its time off and half of its time on. So that will appear to be roughly 50% brightness. So we can do that in our code by going into our void loop and typing analog write LED 0, comma, let's have the LED on full, so we'll put 0 in there. And we'll execute that, upload. Needs to be a comma. There we go. And so our LED's on full. And let's try the opposite of that, so 255. I'll upload that. And our LED will be off. If I go to the halfway mark, 127 or 128, and our LED will be roughly half brightness. Now, it's very, very hard to tell that that is half brightness, but it is on half of the time. So let's change it to something a little bit more, maybe say 200, and we'll notice that that may be a little bit more dim, and we should be able to see that that's a little bit more dim. So as we can see, that's a little bit dimmer than it was before. So let's start to write the rest of our code. Let's work out what we need to have. So we've got, initially we had 0 gave us 100% on. We've also got, and I'll copy this, I left out one slash in there, 255 is 100% off, or otherwise 0% on. And we've got our halfway mark. And we need to work out what 75% will be. Well, 75% on is going to be closer to the 0 mark, so it's going to be halfway of this 127. So halfway between 127 and 0 is going to be our 75% mark. So that's going to be roughly 64 or 63. Okay. Not overly critical if you put 64 in there or 63, and if here you put 128, it's not overly critical. And then we need 40%, and 40% will be roughly 150 or so. So it'll be about 150, and you can calculate that with your calculator. I'm just giving you the number off the top of my head here. So about 158. So this is 150. Sorry, 40%. 152. Alright, so we've got all of the values that we need, and now all we need to do is use them. So I've commented out those. I'm just going to cut and paste them where I need them.